Hi guys, it's Gina, the nerdy math girl, and I'm gonna make your math analysis life so easy. Today we're talking about inverse trig functions, and this is day one of your whole unit. You got this, guys. All right, here's what you have to remember. We gotta start with what our calculator does because that will help you understand inverse trig functions. So right here, here's like the unit circle. By the way, if you don't know your unit circle, go on my YouTube video called, I think it's Unit Circle Made Easy. It will make your life so much happier. Anyway, so if we have this circle right here, if you're looking at what your calculator says, if your calculator is asking for a cosine, your calculator is going to give you a variable in here. It's going to be between 0 and pi. 0 and pi. That's what it's going to do. If it's cosine, if it's secant, which goes with cosine, or if it's cotangent. Your calculator will never give you one of these values in the third or fourth quadrant. Likewise, for sine, and also for cosecant, which goes with sine, and for tangent, we're going to get a value over here, between negative pi over 2 and pi over 2. You will never, ever, for inverses, get an answer in one of these two quadrants. So you just know that right now. You only have to get one answer. You can do this. All right, so here's what you got. Right up here. When this says inverse sine, I don't want you to read as an inverse sine. Call that the angle whose sine is. Every single time. Call it the angle whose sine is. The angle whose sine is 1/2. And if you know your unit circle, then you know that that is right here. Right? That's where the sine value is 1/2. Now look, it could have been over here as well, but this is inverse sine, so we're only getting one solution. It has to be in this principal value region that I just talked about. So the angle whose sine is 1/2 has to be pi over 6. If you have the angle whose cosine is square root of 2 over 2. Again, here you are. You know you have to be up here somewhere because we're looking at cosine. And the cosine is square root of 2 over 2, right in that value, which is pi over 4. If it says arctangent or arccosine or arcsine, it's the same thing. It's just a different way to write it. It just doesn't have that little -1 sign up there, but it's exactly the same thing. So this is the angle whose tangent is 0. So I look at that as 0 over 1. And I think about it, all right, the coordinates over here are over 1 up 0. And so can you see the tangent would be the sine over the cosine, the 0 over the 1. So it would be right here. Now look, it's also, tangent is also 0 over here, but we don't care about that because it's not in the principal value region, which has to be, for tangent, it's the same as sine over here. So that's at 0, my answer is 0. So they get a little bit more, you know, more to them right here. The cosine of 2 pi over 3, you start inside of the parentheses. All right, this is just asking you at 2 pi over 3, what is the cosine? And you should see that it's short and to the left, so that's -1/2. That's what this parentheses is. And then, so now it's asking what is the angle whose cosine is -1/2? And it has to be up here because it's cosine. And, oh look, I get 2 pi over 3. Which looks a whole lot like that. So some of you right now are thinking, I just figured something out. If this is inverse cosine and that's cosine, then that's just the answer. It's a good try, and I like how you're trying to figure it out, but no. And so you can look at this next one and see why that is. So if you look for the cosine of 4 pi over 3, 4 pi over 3 is right here. The cosine there is -1/2. Just like we got up here. So now you need the angle whose cosine is -1/2. Okay, this does have a cosine of -1/2, but it's not in my principal value region, so I cannot use it, right? I have to pick something up here, so therefore I'm going to go here, and this answer, like this one, is 2 pi over 3. Yeah, the reason I put both of those next to each other is so that you don't accidentally think that if it looks like this, your answer is just that. Sometimes it is, but not always. You don't want to live like that. You want to get them all right. Okay, look at this one. You have the angle whose tangent is the tangent of 3 pi over 4. So 3 pi over 4, 1, 2, there's 3 pi over 4. You ought to just memorize you gotta just memorize. The tangent is 1 in both of these spots, so it's the cotangent, and the tangent is -1 in both of these spots. Right, because it's square root of 2 over 2 over square root of 2 over 2. Sometimes it's negative. So there's a little bug right there. I got it. Yay. So you get 1 or -1. So the tangent right here is -1. But if you want to find the angle whose tangent is -1, you gotta be on this side. That's what your calculator thinks, and that's why we're learning these inverse trig functions. So the angle is -1 right here. And do you know what? You have to call it between -π/2 and π/2, which means you have to call this -π/4. Now, I know what you're thinking. You're thinking, I want to call it 7π/4. Why can't I? Well, here's why. If I said, pick a number between 0 and 10, and you're like, 47. See, that's not between 0 and 10. And so if you have to have an answer that's between -π/2 and π/2, -π/4 fits in that, your 7π/4 is way outside of the bounds so that you can't pick that. All right? So you're thinking about the principal value regions. All right, here we are up here. Can you see it? I don't have any idea. I'm moving you. Welcome to the movement. Huh. Okay, so this is tangent of the angle whose cosine is -1/4. That is not on my unit circle. And because it's not on my unit circle, I need to draw a triangle. So the cosine is negative. The angle whose cosine is negative would have to be in one of these top 2 quadrants. I'm going to choose the left one because it's negative. And so here's my triangle. Cosine is adjacent over hypotenuse. So this is -1, that's 4. And then by Pythagorean theorem, you do the 16 minus 1, and you get square root of 15 here. So the question is asking, what's the tangent? And the tangent is just the opposite over the adjacent. From this angle right here, opposite over adjacent, I get negative square root of 15, which is negative square root of 15 over 1. I'm just drawing a triangle. If it's not on my unit circle, draw a triangle. The angle whose tangent, remember that's how you're going to read this, the angle whose tangent is. The angle whose tangent is -3/4. Okay, so it has to be in one of these 2 quadrants, right? Quadrants 1 or 4, because that's where tangent is. That's where the inverse tangent works. And so if it's negative, it's going to have to be in the lower quadrant. Tangent is opposite over adjacent. So here's opposite and adjacent. This is a negative direction. By Pythagorean theorem, this is a 3, 4, 5 triangle, so that's 5 right there, and the sine is opposite over hypotenuse. So from this angle right here, -3 over 5. So easy. All right, remember, if something says arc cosine, that's the same thing as inverse cosine. It's the same thing. It's just a different way to write it. Okay, so if you look at this and you see -1 over square root of 2, first of all, who is allowed to ever do that? You can't leave a radical in the denominator. This number right here, once it's rationalized, is negative square root of 2 over 2, right? So the angle whose cosine is negative square root of 2 over 2, it has to be up here. That's where it is, 3π/4. Okay, listen as I talk about these next 2. Okay. When it says square root of 3, nobody has that memorized. Maybe you do, but I don't. And so here's how I do to get around it. Square root of 3, I'm going to think of that as square root of 3 over 1. And then I'm going to divide the numerator and denominator by 1/2. I can do that. It's like I'm multiplying by 1/2 in the numerator and denominator. So I can do that. And the reason I do that is because this is a sine over the cosine for tangent. And I can see that that's saying the cosine is 1/2 and the sine is square root of 3 over 2. So I go over 1/2 and up square root of 3 over 2. Bam! It tells me right there I'm at π/3. I like that. All right, the angle whose cotangent is negative square root of 3 over 3. So you may be tempted right now to think, oh, I'm going to put both of those over 2. But if you do, then cotangent is cosine over sine. You're saying that the sine is 3/2. And in my unit circle, the highest that a sine can get is right here at 1. It can't go up to 1.5. So I'm going to look at this instead and say, all right, before that was square root of 3 over 3, before it was rationalized, it used to be -1 over square root of 3. Okay, right? If I multiply now by square root of 3 over 3, I'm going to get back to this. So now I'm going to put it over 2 over 2. Love that. All right, this is now the cosine over the sine. And I'm going to come over here so you can see it. All right, remember, cotangent is up here, right? Cotangent is the first two quadrants. It follows like cosine or secant. And so we're going to go backwards a half and up square root of 3 over 2. Backwards a half and up square root of 3 over 2 because that's the cosine and the sine. So my answer is 2 pi over 3. So you don't get all, worried about if you see stuff like this. If it says the secant, the angle whose secant is something funky, flip it over, make it cosine. So this means the angle whose cosine is 3 over 2 square root of 3, right? I just flipped it over. And when I rationalize that and multiply by square root of 3 over square root of 3, I get 3 square root of 3 over, remember that part gives you 3, times 2 is 6, reduce. That's square root of 3 over 2. Square root of 3 over 2. The angle whose cosine, right now I'm looking at the cosine as square root of 3 over 2. Cosine of square root of 3 over 2, right there, pi over 6. Again, if you can't do it really fast, the unit circle values, if you can't do them fast, you need to watch my video because I'm telling you, it makes it so easy. Okay, one more that I need to get you to understand. I need a calculator. Here I go. Okay, look at this last one. Can you see it? It's the angle whose cosine is square root of 7 over 10. Let's say you want to know what value that is. You don't know what it is. Like on some of these up here, we were able to use a triangle because we just wanted to find the tangent. But now if you want to find the value of the angle, how big is the angle? All right, so first, if you're in degrees, I want you to understand it that way. So you're going to get your calculator and make sure it's in degrees. Mine is not. And you hit, I can't see, inverse cosine square root of 7 divided by 10. And you get about 75 degrees. Okay, so this is 75 degrees. So think about where that is. There's 90, right? So 75 is right about there. That's where this angle is. That's not a problem when you have to find it in degrees. It's when you have to find it in radians that all of a sudden people get messed up. So I want you to understand something right now about radians. Okay, if you have a whole unit circle, so just look at your unit circle. In radians, this is 0. This is pi. Okay, if this is pi, that's about 3.14, right? We're just going to call it 3 for right now. Okay, it's rounded. I'm okay with that. I just need to have an idea of what's going on. So if that's 0 and that's 3, then halfway must be 1.5. Right? So 0, 1.5, 3, that means this must be 4.5, and going back around this must be 6. It's really 6.28, right? 3.14 times 2, 2 pi. I just want you to understand that because now if you put your calculator into radians instead of degrees and you hit inverse cosine square root of 7 close parentheses divided by 10, now I'm getting 1.3, okay? 1.3 radians. I want you to understand what that means. What 1.3 means is if this is 0 and this is 1.5, 1.3 is somewhere before that. It's right around where 75 degrees is. I need you to understand what it means when you get these radian numbers so that you can see whether you're right. Okay, so your radians ought to fall somewhere between 0 and 2 pi, which have number values. This is 1.3. Okay, so that is it for this video. I know you learned a lot. You can pause me anytime you want. Come back for number 2. I'm gonna make this unit super easy for you. I am Gina. Tell your friends.